Two unknowns, how many equations do we need? Two equations, how many bodies? One body.
They don't want the force equation, they want the coefficient.
Right.
So,
Andrew?
Would we consider putting a moment for the twisting of the cylinder?
No, because there's no concentrated moment on here. It's going to experience a rotational motion, but I'm not sticking a screwdriver in there and spinning it. It could experience a rotational motion, just like it could slide down or slide up. It could experience a motion. We're trying to prevent any kind of motion, but there is not a concentrated moment on it.
three unknowns?
Okay, so we have WC, you see there's two W's here, so since the picture shows W, let's call that W. And then call WC the weight of the cylinder. So we have that, but we don't have W, we don't have the frictional force, we don't have N. But what am I leaving out of this table? Mu is still an unknown, right? So mu is an unknown too, so we really have four unknowns here. Four equations. How many bodies do I need?
But isn't the mu taken care of by the frictional force?
It relates the two, but you need another equation. Don't you need four equations here? Because if you find n, you're going to need an equation to find n. The frictional force will not allow you to find the frictional force because you don't have mu. And then you're going to need another equation to find W. Does everybody see that? You're going to need one static equation to find N. When you put in the frictional force, you could find the friction, but you need to know mu still. So you're going to need another equilibrium equation. And then to find W, you're going to need a fourth. Does everybody see that? So for four equations, how many bodies? Don't call it out yet. Think. It's a frictional problem. It's a 2D problem. How many equations do you have? Now call it out.
One.
How many equations? It's one body. It's a friction problem, and it's 2D. How many equations do you have? You have four equations. Some of the forces in the x equals 0. Some of the forces in y equals 0. Some of the moments equal 0. And the frictional equation. Okay, so what forces do we have? So in any case, we need one body. So let's go ahead and draw the body. We don't know how many equations we need. We know we need somewhere between 2 and 4 equations. So should we draw it in the center? Okay. So we have this W coming off here, right? We have WC here. Where's the normal? The normal is going up like this, right? And it's going to be 30 degrees. And where's my friction? Good. So think about what's the most likely impending motion? Down. Does everybody agree? Most likely down, right? These two things here, these two weights are pulling it down. Okay? So the friction, if the motion is going down, which way is the friction? Up. And you see what the distance is, right? This radius right here is 12 inches, and this radius right here is 8 inches. So what's an unknown? The WC is given, right? 250? Okay. So this is an unknown, this is an unknown, and this is an unknown. What do they want us to find? W and mu. So what is Dora? No. So Isadora wondered, could I just put the friction here at the center point? No. You have to draw this whole body because we're including moment equations now. If you put the frictional force in the center, you're saying that it's not creating any rotation, but it is, because it's at a distance. You have to draw the whole body and have the forces, WC goes through the center, N goes through the center, W does not go through the center, and the frictional force doesn't go through the center. Really important. Peter?
It's the same in this problem, because it won't create a moment, but does N stop at the center, or does it,
Say that
the
again?
normal force go to the center?
No, I guess, no, you're right. It should be just here,
But it's that
Right.
big there?
but let me do this,
Okay,
because I want to show that it goes through the center,
okay,
okay?
thank you.
And let's just call this point right here O. Okay, so, first of all, how do we want to put our axes? Do you want to put your axes like this, or do you want to put your axes like this? So let's think about it. If we put it like this, two forces are in that direction, right? The two W's. And if you put it like this, these two forces are in the direction, right? Of these four forces, which is the easiest force to work with? Well, this way, because it's given, right? You know that value. So I probably would prefer to rotate it, because these are weirder forces. I don't know, they're unknowns. I probably would prefer that. So I'm going to do that. And I didn't even explain that well, did I? This one is easy to take components of. 250, because we already know the values, right? It's 250 times whatever it is. So I much rather do my axes not in that direction. Okay, so let's look at we know we have four equations. Sum of the forces in the x. How many unknowns are going to be in that? What's going to be in the sum of the force in the x? The frictional force, which is unknown, and both weights. So I'm going to have how many unknowns in the sum of the forces in the x? 2. Sum of the forces in the y. 3 forces, but 2 of them are unknown, right? Okay, how about sum of the moments? Where could I do sum of the moments? Could I drop out something? It would still be 2 unknowns, right? If we do sum of the moments about the center, which ones drop out? WC and the normal. So we still have 2 unknowns. So all the equations have 2 unknowns, so let's just do them. So sum of the forces in the x equal FF minus WC times, say it again, cosine 60. Is it a negative? Yeah. So I really should be doing, shouldn't I really been doing this? WC times the cosine of 60 plus 90, 150, no? Right? Did I do that right? 30, no, it's 120. 120. Because the force is here, and I'm bringing it up to here. It's the theta x is 120. Okay, plus W times cosine 120 equals 0. Sum of forces in the y equals N minus WC cosine 30 minus W cosine 30 equals 0. The frictional force is mu times N, and sum of the moments about 0 is FF times 12 positive, and W times 8 negative equals 0. And in the end, these are the values. W equals 750 pounds. The frictional force is equal to 500 pounds. Normal is equal to 866 pounds. And mu is equal to 0.577. So this is what the solutions are from those four equations, four unknowns. So what was the question? It said, determine the weight W and the minimum coefficient of friction between the inclined surface and the cylinder. You did it.